Yeah, thanks, Bez. Hi, everyone. I'm James Devine. I'm a researcher at Microsoft Research. Thanks for the intro, Blaze. And I'm going to talk today about the microbit and accessibility. Um, and the first thing I want to bring up is that accessibility or disability is a very important topic. It's also a very sensitive topic. So I just want to be clear, I'm still learning. If I need some further education, or if I say something that is perceived to be incorrect, please do reach out to me on either Twitter or through email, and I'll happily address whatever the issue was. So a rough outline of the talk, actually it's a very precise outline. The first thing we're going to talk about is disability broadly. We're then going to move on to talking about assistive technologies that we can use to counter disability to an extent. Then we're going to cover building assistive technology with only a microbit. Then we're going to talk a little bit about a new hardware prototyping platform we've been working on for the past 2 years called Jacdac, and how we can use Jacdac and the microbit to empower more people to build assistive technology. And so to start off with, what is disability? I always find this to be a mind-blowing statistic, right? I mean, over 1 billion people around the world live with some form of disability. And we all have our own sort of connection to disability. Maybe you have a family member who has a disability. Maybe you teach a student with a disability, or maybe you even have a disability yourself. And there are, of course, many different types of disabilities. Some of them are invisible, and some of which are quite apparent. And we're going to be particularly covering physical disability. Now, I was reading a few months ago about the different categories of disability. I didn't really realize that there could be such a thing. But as I say, I'm always learning. There's kind of 3 categories of disability. The first is permanent disability. So, for example, a person who is completely paralyzed has a permanent mobility impairment. Then you might think temporary. So if you've got permanent, what does a temporary disability look like? And so perhaps if you've broken your arm, you have a temporary mobility impairment. And then there's a third type, which is situational. And so you might think, well, what does situational mean in this context? How can you be situationally disabled? And one example of this is perhaps you're carrying a large box, and therefore you have a situational mobility impairment. Regardless of your current interaction with disability, it's likely at some point that someone close to you or even yourself will develop a disability. So it's important we think about accessible technologies. And the other thing I'd like to sort of call out, that maybe if you're an educator, you might consider introducing accessibility and accessibility style lessons, like design lessons around accessibility to your students, because a lot of the reasons why the technology we use today isn't very accessible is because it wasn't designed with accessibility in mind. And here's a great example of designing for accessibility being beneficial to everyone. This is just a random YouTube video of Would I Lie to You? And you see that there's closed captions, and closed captions were originally created for people who are deaf or hard of hearing. But actually it's really beneficial to everyone else who watches and consumes media content. Perhaps your fiance's just come in after a long day and you've been, you want to watch your video, but you don't want to annoy her. That's a very real scenario sometimes for me. And so I love closed captions too. Okay, so that was a little bit about disability. I'm now going to move on to assistive technology. Wow, look at those PowerPoint transitions. Okay, so we can use assistive technologies to counter disability. So why do we need to counter disability? Well, as I mentioned, most of the devices we use aren't necessarily considerably designed to be accessible first. This is changing. You can see the profile of accessibility has risen over the past decade or so. And as I mentioned, specifically in this talk, we're going to be considering physical disability. And so here's a little thought experiment for you. Have you ever thought about trying to use a desktop PC or a laptop without a keyboard or a mouse? Just have a think about that for a second. I'm sure a few of you are mousing around in other web browser windows or interacting. Maybe you're doing work, maybe you're typing right now. Well, that would be super difficult without a keyboard or a mouse. Can you imagine not doing it with those two things? Fortunately, there are some PC accessibility options that we do have available, and there's a huge amount of them, but I've just kind of picked some highlights here. So perhaps you can move a mouse, but you lack the fine-grained motor control to actually, perform left click and right click. And so you might think to yourself, so you can move your mouse. Okay, I'll use my feet. Maybe I've got full control over my legs. And so you might actually purchase the X Keys foot controller, which is on the left-hand side of the screen. And therefore, you can then click with your left foot and right foot to perform left and right click. Perhaps you can only move your fingers. In which case, so you can't pick up your mouse and move it from side to side. You can only perform minute actions with your fingers. In which case, the trackball mouse might be the best option for you. Instead of having to move the mouse around, you actually use the big yellow ball in the center of the mouse to move the cursor around your screen. If you're blind or visually impaired, you might consider using an Orbit brailler, because you obviously cannot make out the keys on a keyboard. And so the braillers are kind of an interesting device because you've got both input and output on the device itself. So at the bottom of the device, you've got braille cells that if you highlight text on something like Word or a text editor, you'll be able to see those ASCII characters in braille at the bottom of the display. And those big white buttons sort of positioned like this, if you were to look at my hands, those are for actually inputting braille characters and having them appear as ASCII. And if you can't move at all, perhaps the eye gaze tracker is for you. And so you can navigate your personal computer using just your eyes. But if you don't fit into any of these existing device categories, you need something a bit more specialized to you. And for that, you kind of look at this ecosystem of access switches. Now, access switches are incredibly simple. It's a switch that I can click. You might be able to hear it. On one side, and on the other side, you've got a 3.5mm jack. And these access switches plug into access switch input boxes. So I can just plug it in there, like that. And if I had my X Keys box hooked up to my PC, I'll be able to control my PC using just a switch. And you get various types of these different switches. You can see, access switch input boxes. You can see one of them at the bottom left-hand corner of the screen, which is the Hitch 2. You can see some of the functionality it has by default. One of the modes is, acting as a mouse. So you can map 5 different switches to 5 different mouse interactions. And then you've also got other modes which you can explore. And you also get a whole host of different switches. For example, you can get a big round plastic one, or you can get a super soft pillow-based switch if you don't have that fine-grained motor control. And the other thing is that switch access is widely adopted. You've got devices like the Xbox Adaptive Controller that you can use with your Xbox. And you've got these assistive toys that allow someone to experience the pleasure of triggering like either a voice action or having the elephant move using access switches. And in terms of interacting with personal computing devices, here's a couple of examples. So I'm just going to go through the iOS example here. So when you're in assistive switch mode, you get this blue column that scans across the screen, and you push the switch and it stops at a particular point. And then you get a vertical bar that goes up the screen. And through doing that, you can pinpoint, you see here, you can pinpoint a particular application. Okay, so how do we build assistive technology with the microbit? And so to do that, I'm going to introduce Matt Oppenheim. He's a visiting researcher at Lancaster University, and he's also an offshore engineer. And so for periods of time, like 6 months or so, he goes and maintains expensive machinery. His background is in electronics, and he's also pretty good at drawing cartoons. That's his cartoon of himself. His contact information is there, and all content is provided by Matt. So thanks a lot to Matt for this upcoming section. So when Matt isn't offshore around the world somewhere, and he's in Lancaster. He actually consults at Beaumont College, free of charge. And Beaumont College is a local school in Lancaster that specializes in people with severe disabilities. And they provide these people with new and interesting experiences. And they also have on-site occupational therapists to help experiment with new assistive technologies. And so occupational therapists, they typically are really good at mechanical modifications. And this isn't an example provided by Beaumont. This is just an example from the Microsoft resource. And you can see actually 2 joysticks here have been specially adapted for the person in the wheelchair. The left-hand joystick has actually got a soft felt on top of it. And you can actually see that the person's wearing on their wrist a Velcro pad. And so that allows them to use the underside of the wrist to actually control that joystick. And on the left-hand side is another joystick that locks into that person's palm. And so occupational therapists are really good at these kind of mechanical adaptations. But what if you can't use any of this existing switch technology? What do you do then? Like, what if you don't fit inside these boxes with access switch technology? Well, Beaumont actually came to Matt and with some examples of this. For example, one student could only move a finger, and so they didn't actually have the strength to operate a switch. And another student could only move their wrist laterally and not very reliably. So obviously they don't really fit into this ecosystem of access switches. So you need someone to come along and build some new assistive technology. And so that's what Matt did. So Matt came up with one particular answer around flex sensors. And flex sensors are a super interesting type of sensor. They allow us to detect the amount of deflection or bending of the sensor itself. And this is especially useful if you have limited movement. For example, here's some pictures courtesy of Matt of different ways you could think about using flex sensors. And so if you had a flex sensor on your thumb, you could measure the amount of bend just from having it attached to your thumb. And you can think about other ways in which this could be used. And here's where the microbit came in. So Matt then built a system using 2 microbits. One microbit was connected to a flex sensor. And when that threshold of the flex sensor hit a specific threshold, it sent a message wirelessly to another microbit that was plugged into one of those access switch input boxes. And so very quickly, you can build up a new type of switch for this access switch input technology. Underneath the lovely yellow cases are a couple of modifications to edge connectors. For the flex sensor, the transmitter side of things, you've got an edge connector with some electrical connections to the flex sensor. And on the receiver side, you've got another edge connector that's been modified to electrically connect to an audio jack, just like with a normal access switch. Of course, he 3D printed a case, and I understand this was quite an involved and iterative process. And this was to ensure that the devices didn't cause any irritation and were safe to use, basically. But in short, we need more people like Matt. There are an insurmountable amount of people around the world that need this kind of custom technology, and there's few Matts in the world to help build these kind of technologies. So it's not like overnight we're going to transform every person into an electronics engineer capable of doing these kinds of things. So we need to lower the barrier entry for people to build assistive technology. Okay, just going to take a sip of water. Okay, so that was building assistive technology with the microbit. Next, I'm going to talk about Jacdac. So everyone's probably on this call quite familiar with programming a microbit, so I don't need to go on about it, but it is super easy. We've got a wealth of different programming editors from Scratch to microblocks to MicroPython to MakeCode, and they all make programming a microcontroller, in this case the microbit, easier than ever before. The other thing that's super easy is connecting a single accessory to the microbit. You can see all of these fantastic accessories available on microbit.org that you can buy for your microbit to make computer science education, that more engaging. But if you ever want to do anything more than that, it becomes a bit more complex. Like sometimes you might have to get out a breadboard and make individual electrical connections, and this is hard to do, let alone in a classroom environment. And you might say to yourself, well, James, there's all of these modular solutions that exist today. Well, they might solve the electrical interconnectivity problem, but in terms of software, there's still quite a lot of barriers there. You have to work out what particular library you need to use. And so you really need to have an understanding of kind of the lower level protocols and how they all work. So what we've been working on for the past couple of years is this new prototyping technology called Jacdac. And it's a way of bringing a plug and play experience down to low cost electronics. And what we often like to do is liken this to USB, but for low cost microcontrollers. If you think about USB, when you're plugging a mouse into a computer, you don't really have to do much else most of the time. You plug in your mouse and your computer knows it's a mouse, it knows how to talk to it, and your mouse is ready to use within a few seconds. And so we want to create that same experience for physical computing and for the microbit. And on the left-hand side, that kind of captures the experience we want to create. We've got a microbit. Connected to that microbit is a Jacdac adapter. And hanging off that microbit are a whole bunch of sensors that are connected using a reversible low-cost cable. And so you can plug these devices in any which way. They will all connect together, and you'll be able to use them in your MakeCode or other programming environments programs. And so now I just very want to quickly create a flex sensor demo using Jacdac, MakeCode, and the microbit. Okay, right. Let me just transition. Oops. Okay, right. So that was fairly straightforward. Okay, so I'm just going to focus my camera to my desk. Hopefully that's coming through okay. Yes, it is. Okay, so on my desk you see a microbit, and on the screen share you see MakeCode. So I'm just going to make a new project. I'm going to call it Flex Sensor. Just going to create it. Great. So I've got my microbit on my desk. It's got nothing plugged into it. I'm gonna attach a Jacdac adapter, which looks like this. I'm just going to plug that into the bottom. So now the one thing I need to do is add the Jacdac extension in MakeCode. I'm just going to do that. Jacdac. Okay, so now our MakeCode editor is Jacdac enabled. And so what that means is I can get a device like a slider. I can plug it into the bottom of my microbit, and you'll see a simulator has appeared for my slider. So if I slide it up and down, you can see the value changing in real time. But of course, I promised a demo using a flex sensor, so I'm going to get one of those. I'm just going to plug it in. If I can do it. There we go. And so you'll see as we bend and flex the sensor, its value changes. Now, the other thing we have in Jacdac is a USB module. And I can use this to control my computer using a mouse and a keyboard. So I'll plug that into my bus too. And you'll see, hopefully, if I scroll down, that we've got a keyboard and mouse simulator appear. So if I go to my modules category, which was added when I added the Jacdac extension, you'll see it's pretty bare at the moment. There's nothing there. And so what I'm going to do is click the Add Blocks button, and it will automatically detect what I've got plugged in and install the corresponding packages for them. And then we'll get the lovely blocks that we're all so familiar with. So if I open my modules category now, you'll see that I've got blocks for my flex sensor and for keyboard and mouse. So I'm just going to grab the flexing block. I'm going to use it. So what I want to do is, if we bend the flex sensor, you'll see that its value changes, to around 40 when I've got it flexed, a significant amount. Maybe you can't quite see that. So I'm going to have an if statement that, oops, I'm now looking at the wrong screen, that does a check to see if the value is greater than 40, the value of the flex sensor is greater than 40, which one? 40, and then I want to use it to move my mouse along the screen. I do -5. So when I bent it, my mouse cursor should move to the left. And the other thing to mention is that the simulator also participates as a Jacdac device. So I don't actually need to download my code to the browser in order to inject mouse event to the microbit in order to inject mouse events. So if I bend this now, hopefully you'll see my cursor move. You see it move along the left-hand side of the screen? And there you go. So that was a very quick demo using Jacdac. I can, of course, deploy it, but I think we're probably running out of time. So I will go back to my presentation and we'll resume things shortly. If you just give me 2 seconds. Okay. Okay, we should be back. I'm just going to take it for granted that we're back. Okay, so if you want to learn more about Jacdac, then please go to Pelly's talk, which is happening tomorrow on the 4th of December. He'll be going into all of this technology in a lot more depth. Okay, so the final topic is piecing this all together. How can we empower people to build assistive technology using Jacdac and the microbit? And so to do this, I want to talk about a project we worked on just over the past few months. It was called Project Make Accessible. And the idea behind Project Make Accessible was using these 3 technologies, MakeCode, Jacdac, and the microbit. Can we empower more people to build custom accessibility devices? And so now it's time for a short video. You've heard enough from me, so you can hear from someone else for 3 minutes. Okay, so Blaze, it'd be great if you could let me know the sound's coming through. Okay, thanks.
Yep,
Disability is part of being human.
Yep, sounds good.
We all face a permanent, temporary, or situational disability in our lives that will impact how we use technology. Off-the-shelf accessibility solutions often require further customization, which is slow, complex, and limits available solutions.
It is very variable what their abilities are. We just find like the more ways that someone can access something, the more efficient it can be, so that you don't have to rely on one method.
We need easier and quicker ways to build and adjust assistive setups so that everyone can contribute. In this hackathon, we tested a device creation platform called Jacdac and learned how it could empower more people to build flexible, custom assistive technologies. Jacdac makes it easy to build custom devices from low-cost hardware and low-code software. Using reversible cables, hardware modules are instantly recognized as you connect them and can be programmed to work together through simple drag-and-drop programming. Devices can also be easily reconfigured through Jacdac without any programming at all. We distributed Jacdac hardware kits to Microsoft hackers and NGOs to answer the question, could more people create assistive technologies using Jacdac? The answer: yes, they can.
It would be super useful to have an easy, like, let's reconfigure this keyboard without researching which software you're going to download and will it be USB.
I have a daughter who have a genetic disorder. She has a problem with her speech. Communication with her is definitely a challenging one, especially for her to communicate her pain and problems to us. With the Jacdac, based on the buzzer that she clicks, it will create an alarm for us.
What if you can't interact with devices with your voice? Audio assistive tech can be expensive or hard to use. With Jacdac, we built a button-to-speech interface that gives a voice to those who can't use their own. What if you don't have fine-grained motor control and want to use Teams? We created an accessible Teams interface device, making it easier to raise your hand, toggle mute, upload, and so on.
Creating a solution using a Jacdac, it's amazing. It's amazing.
Distance from idea to implementation is really, really short.
Just connect your sensor and it just works.
It would be suitable for people with different disabilities.
Disability spectrum. And Jacdac allows you to sort of have an affordable spectrum of tools that you can kind of modulate, grow, or customize.
We envision a future where everyone can interact with any device. Microsoft products should support an open standard like Jacdac, while working with other tech companies to create a new, accessible hardware ecosystem. This is a critical step towards empowering every person on the planet to achieve their full potential.
Great. Okay, so that was a little bit about Make Accessible. So as mentioned in the video, it was an internal company hackathon, and we engaged with 3 external NGOs who gave us feedback and tested out and built various assistive technologies using the kit we sent. We had over 80 hackers from around the world, and for those who wanted a hardware kit, we also distributed those kits around the world. And what was in a hardware kit? Well, in each kit, there was a microbit, a Jacdac adapter, some cables for connecting modules together, and we also asked hackers to fill out a form and tell us what their intended application was that they wanted to build with Jacdac. And we actually tailored each kit that we sent to each person with a suite of modules that we kind of aligned to their application. The most important thing that we distributed alongside hardware kits were Jacdac snacks, or Jack snacks for short. And these are basically just M&Ms embossed with a Jacdac logo. But they were very well received all in all. So what did people build? You saw various snapshots of what people built in the video, and you can see some of those playing in miniature on the screen in front of you. We had people experimenting with accessible interfaces for Microsoft Teams. We had students building deaf and hard of hearing floor finders, like, for example, if your elevator doesn't announce what floor you're on, how does a deaf person or hard of hearing person work out what floor they're on? So they actually used the microbit with proximity to kind of work out which floor they're on. We also had people looking at integrating Make Accessible, Jacdac, and the microbit into Minecraft Education Edition, which was super interesting. Oh, Braille was also super cool. And here someone was looking at ways of making the microbit a bit more accessible using Braille displays. But I do want to call out one particular workstream, which was this button to speech workstream. So this is Yara. She's 6 years old, and like any 6-year-old, she absolutely loves Baby Shark. And if you're not familiar with Baby Shark, I'm just going to do a quick rendition. Unfortunately, it's not drumming, it's singing, which is I'm substantially less good at singing. So here you go. Baby shark, do 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 do. Baby shark, do do. Oh, okay, and it goes on and on like that for like a long time, and you go all the way to Daddy Shark and then back to the beginning again. In any case, she absolutely loves the song. However, Yara suffers from cerebral palsy, and this impacts her in various different ways. She has various spasms, and she also has difficulties communicating using speech. She also has a sister, and her sister doesn't suffer from cerebral palsy. And so it's really frustrating to Yara to see her sister do things that she cannot. And one of those things is interacting with smart assistants. And so this is a video of Yara trying to use Alexa.
I didn't hear that. Please try that again. I didn't hear that. Please try that again.
So you can see that Alexa or other smartphone assistants, sorry if I've just triggered your Alexas, I just triggered mine. She has difficulties understanding what Yara's saying. But this isn't just specific to smart assistants. People Yara interacts with might have difficulty understanding what she says. And of course, you can get speech assistive technology that utters specific phrases and allows you to push buttons and build up phrases. However, it's not exactly designed for Yara's needs. Yara, as I mentioned, suffers from spasms, so she doesn't have the ability to pinpoint various points on a surface like you would have to do if you're pushing buttons. So using Make Accessible, can we build something a bit more customized? And this is what we built for Yara. So you can think of this effectively like a handheld stool that you can place on top of various smart assistants, or you can carry around with you. Inside the plastic top is an integrated speaker, a text-to-speech Jacdac module, and a microbit. And that microbit has been loaded with various different phrases And you can actually, Yara can actually swap different phrases on and off the microbit using Jacdac and a web page. To navigate through the phrase bank, there's a rotary control, which you can see integrated into the top here. And once she's selected her phrase, you can hit this button and that phrase is spoken out into the world. And so here's a video of Yara using her device.
Baby Shark by Pink Farm, sure. Playing on Spotify.
Okay, I believe that's all I've got time for. I'm happy to take questions, but you can see how happy Yara was just with such a simple device that was put together in a day. And this is really what we're trying to enable. We're trying to enable more people to build assistive technology. So thank you for listening. Please do reach out if you have any questions, comments. I'm always available. Thank you very much. Probably back to you guys.
Thanks so much, James. Really appreciate it. Before we close out the session, we definitely do have some questions that I just want to make sure we get through before we're out of time. So we had a question earlier and I may have answered it, but definitely want to double check based on your feedback. So someone was asking if there's an advantage to using wireless transfer between the sensor and computer instead of direct wire connection. I was thinking it was maybe cable management, but I'm not sure if you have any more feedback on that.
That's precisely what it is. And also the other thing would be the flexibility in mounting options. So you can see that Matt, presumably we're talking about the flex sensor with the 2 microbits. But if you've got a big bulky power supply that's mounted on your wrist, you're less inclined to use it. It's going to be less comfortable than, and also if you've got a cable running all the way to the device, it's likely that will impact the movement of your arm, which it's already impacted as it is with disability.
Okay, that's perfect. Great. I believe someone hopped in with their own recommendation, but definitely would love to see if you have any suggestions. Someone was wondering if there's a more accessible solution that you know of for breadboard prototyping.
So hopefully someone being Steve or Paul might have jumped in with that, but there's or Kirsten's on the call probably. So there are a few breadboarding blind accessible breadboarding publications that I'm happy to share if you email me, which I've stopped sharing my screen, but you're happy to, we'll work it out. And then there's also the Blind Arduino blog. There's a really fantastic blog about using Arduino if you're blind. And so that has some really fantastic resources. And also there's the New York Public Library have actually run specific blind Arduino sessions. And so that's run by Chancey Fleet if you reach out to her on Twitter. Again, I can also put you in touch.
Amazing. And that's why I double checked with you, because you had way more solutions than what was recommended in chat. So that's amazing. So 2 more real quick ones. And I think they may have been answered already by, I believe it was Peli. Hopefully I'm pronouncing that correctly in the chat. But we just had a couple of quick inquiries asking how they can get Jacdac and how they can be a part of the next round of hacking. So I believe Peli mentioned that will be addressed in tomorrow's session.
Exactly, spot on. I will say no more. Peli's the person. Please attend his talk, and I'm sure you'll be surprised. I don't know.
No, that's perfect. If it's addressed tomorrow, then we can leave it till then.
I believe it's addressed tomorrow, so please do attend.
Perfect. Okay. Well, with that being said, I'm sorry because I know everyone we're going just slightly over time, but please, everyone, please hop in chat, send our praise, send our thanks. James the Devine, thank you so very much for your incredible, inclusive and accessible session. It was really amazing. Like I remember just super quick seeing the Xbox Adaptive Controller when it first came out, and the only switches available for it were through AbleNet, and they were so expensive for a single button. And all I could think of was we need more accessible and cheaper solutions. So it's, things like Jacdac and that are contributing to that cause. And it's just amazing to see it in the works. So thank you so much for your session and for all the information. With that, everyone, please, feel free to leave the session whenever you're ready. That's it for today. We do still have our closing remarks, but I hope you all have a wonderful rest of your day. And we'll be right back at it again tomorrow. So James, thank you again, and have a great day, everyone.
Yeah. Thanks, everyone. Thanks, Blaze.
Thanks, James. Bye now.
Bye.